optimization. And the first thing that you must know is that if you can't beat us, you simply have to subscribe for us, and that will be much appreciable. So now, this type of question, I think this was on 2024. I don't know whether it was on final or somewhere in some of the trials or June. I forgot about that. So now this question was saying Jane wants to cut the circle out of the rectangular piece of cardboard of 2 meters. Okay, that's the length and long, or 2 meters long and 4x meters wide. The radius of the larger circle, which is this one, is half of the width. So which means this is actually 2x. Okay, fine. And then they further said that, oh, it is half the width of the cardboard. And the smaller circle has a radius which is 2/3 the radius of the bigger circle. So the radius of this one, radius of that one is actually 2/3 of what? Of 2x. This is what they mean, 2/3 of 2x. And then they said, the first question says, show that the area of the shaded region is A is equal to 8x minus 52 pi x squared divided by 9. So what do they want you to do here? They want you to take out the circles, because the shaded area or the shaded region, it is where there is no circle. Okay, so you must take out the circles over there. You just subtract the circle. So everything, this guy, that is the area of the circle. If you manage to show the area of the circles, you are very much proper. You're very much good in that case. So, okay, how do we do this? I'm going to express the area of each component that we have that we're going to talk about. The first one, I'm going to talk about the rectangular piece. We have area of a rectangle. You know that area of a rectangle is simply length times breadth, okay? Of which, what is our length? Our length is actually 2 meters. So we have 2 multiplied by what is our breadth? 4x. So which means this is actually 8x over there. That is our area of the rectangle. Okay, fine. So having done that, it is 8x meters. Having done that, now let's express the area of that guy, of the larger circle. Area of the larger circle is actually, let me write them here. Area of large, I'll say area large. That is actually pi r squared. And please, just take a moment and fight to understand the formulas: volume, areas, what do you mean? Perimeters, and so on. All those formulas, they will help you a lot. So here, we know that our radius is 2x. So which means I have pi into 2x squared, which is basically pi, or let me just say, let me write it in a proper way. I'll say this is 2x squared and pi over there. And it's not 2, it's 4. Sorry about that. Must be 4. Yeah. It's 4x squared. That's going to be 4x squared and pi. But what about the area of the small? Area small. I'm going to do the same thing. Pi r squared, which is the radius. Now, we are okay, pi, we are fine. What about the radius? They said that the radius of a smaller circle is actually 2/3, 2/3, yes, of the larger circle, which is just 2x, and then squared over there. Of which this one, when you simplify this, you're going to actually get you have pi into, this is 4/3x squared, of which at the end of the day, when you factor out everything, I think, let me verify from my calculator. because I want to do this part by part. 4 over 3 squared. That gives me 16 over 9. So that's pi, or 16 x squared pi. Yeah, 16 x squared and pi over there. So now we are fine. We have the areas of everything. So I told you to find the area of that thing, find the area of the shaded region. We just need to simply subtract, which means what are we going to do? We're going to say area, or the area of the shaded region, must be equal to the total, the total of the rectangular, which is 8x. And then we're taking out the circles. Then we'll be left with the shaded region. So it's minus 4x squared pi, and then also minus, this one is 16 over 9, minus 16 over 9 x squared pi over there. So all right, that's fine. So when we work this out, that means you have actually 8x, and then on that 8x you have 4. And just say, and get these ones are like, they are similar to each other. Okay, if those ones are similar, let's just work the digits themselves. So actually negative 4 minus 16 over a 9, that will give me negative 52 over 9. And then from there I'll just say pi x squared, just like that, just like that. And then you're sorted, you're sorted. So you can do everything, all those things in one step or in one equation. But if you don't want to be confused like myself, you can just break them down. And then from there, they said, determine the value of x such that the area of the said shaded region is a maximum. So now that means we just have to apply derivation from that thing. The value of x, we're required to find the value of x. Okay, so which means we need to solve the value of x. Okay, fine. So now what we're going to do to derivate that thing. Okay, now we are fine. We can derivate that thing for as far as we're concerned, because we don't have a variable dividing over there. So which means I will just apply the derivation. The first derivation must be equal to a 0. So that means I have actually 8 minus, okay, fine. Okay, fine. So what I'm going to do, I need to multiply or to square. Yeah, I basically need to square 52 divided by 9 squared. Not squared, multiplied by 2. I mean, yeah, I must multiply by 2 when I'm applying derivation. Yes, this one I have to multiply those things. And then I get 104 over a 9. And then pi and x. I'm left with x now. Okay, fine. Having done this, or having done that in this case, this must be equal to a 0. Fine. I will take this 8 to the other side, or this thing to the other side, so that I can have 8 is equal to 104 pi x, and then divided by 9. And then from there, what I can do, I can just divide both sides by that thing. Okay, so that I can be left with x, which means when I divide there by that number, I will be left with x. And then this side, when I divide 8 divided by that number, I will eventually get, or another simple way where we can do this, because I might lose some of the students. Let me go back and not apply that method. The first thing that I'll do, I will multiply both sides by 8 by 9. So actually I will get 72 is equal to 104 pi x. And then from there I can divide by 104 pi. 104 pi over there. And then my x will be 0.22 meters over there. That's my value of x. That's my value of x. So from there, the last question says, calculate the maximum shaded region. To find the maximum, we now have the value of x that will make that thing a maximum, the shaded region a maximum. So which means I'm just going to substitute this value of x in the place of the area. 9.3, my a must be equal to 8 into 0.22 minus 52 over 9 pi into 0.22 squared. And then this will eventually give me a 0.88 meter squared. You know, an area must be squared. And as simple as that.